Now let us explore the second part of visualization using a advanced library, that is Seaborn. So Python has several libraries for visualization. So here we are going to learn about Seaborn library. So at the end of the session you will be able to understand and work on Seaborn for visualization of data. We will learn about different visuals such as advanced visuals such as strip plot, distribution plot, joint plot, violin plot, swarm plot, pair plot, count plot and heat map. These are advanced visualizations which is not possible using the matplotlib libraries. So that is why we require Seaborn. So let's focus on visualization using Seaborn. So Seaborn is a data visualization library similar to matplotlib. It is built on top of the matplotlib framework. So it is actually using matplotlib as a base package out there to create visuals. The basic functionality of Seaborn library is that it allows comparison between multiple variables. It supports multiple plot grids. It is univariate and bivariate analysis, both can be done here. It is available for different color palettes, and it estimates and plots linear regression lines as well, which is not quite possible using the matplotlib library directly. So if you want to install and get started with Seaborn, you have to write the code such as conda install Seaborn, or you can write pip install Seaborn in your terminal or in your command prompt. If not, if you want to do it with the help of Jupyter Notebook command line, so you can use exclamation pip install Seaborn. So this exclamation basically skips out the execution of the code from the command from the Jupyter Notebook. It will go directly to your terminal or your command prompt, and you have to import it with the help of the same syntax, import Seaborn as SNS, as we have done for other libraries as well, where SNS is an alias for Seaborn, because we cannot keep on typing Seaborn all the time. So let's try creating the first chart, that is the strip plot. So strip plot is a plot which is similar to the scatter plot with one categorical variable into it. It is similar to the scatter plot with one categorical variable, and one axis represents the categorical variable and other represents the value corresponding to that category. So it's very easy. Here we are taking the Titanic dataset, but we will work on the same insurance dataset to create this strip plot. And we will try to create a strip plot where we can mention the strip plot with the help of the strip plot function, and we can create directly. We do not have to do more coding over here because it is an advanced library. All we have to do is pass in the data, and it will automatically detect the information which is there. It is similar to bar plot, if you can see, but it gives more clearer visualization of your data with the form of strips or dots of data. So let's create a strip plot for our data as well. So this is our matplotlib library for the first part. I'll call it as a data visualization part 1, and I'll create a new part 2. So this is a part 2 of data visualization. So as I discussed, we have to import Seaborn as SNS. So we will import, first of all, we will import pandas. This is a new library. So import pandas as PD, import numpy as NP, and we will also import matplotlib, because as we know that base matplotlib dot pyplot, and at the end we will import Seaborn as SNS. You can see it clearly that we are importing all of it, because although we have to create this chart, we will use data for it. So data is needed, and then we will require pandas and numpy. Seaborn is based out of matplotlib, because so if it is based out of matplotlib, we have to open and close the canvas of our chart. And let's try importing a data set, that is df is equal to pd dot read underscore CSV, and here we will pass insurance dot CSV. So we will import this data. You can see clearly this is our DF insurance data set. Now we will create a very simple Seaborn chart, that is strip plot, SNS dot strip plot, and we will call the strip plot. And the best part is we do not have to write the data frame entirely. We have to pass in what is going to be on the x-axis, what is going to be there on the y-axis, and what is data. That's it. We just mention what is there here in this. You can see data, and then what is there on the x and what is on the y, and color based on what you want to give the colors. Okay, so let's try to give this x-axis, y-axis readings. So as discussed, it is a strip plot. It requires categories on x-axis. So I will take region as the categories over here. So I have to simply pass the region, and y I will take, say, claim. It's our all-time favorite, claim, and we will call the data df, and you can see this is the strip plot. Now in this strip plot you can see it is having the same color all the time, like for southeast, northwest and south, all the region, all 4 region, different column should be there. So if you see this hue, automatically it is detecting in the chart that has generated. Right now it is not generating because I will do one thing. I will use plt.show to stop the canvas. Okay, there is an option of hue. You can see hue is equal to, and then you can specify, okay, you want to give color with respect to region, so you can give color with respect to region, and a different region will have different colors. You do not have to mention the legend as well. It will directly create the legend. So you can increase the size of the chart by using plt.figure, and plt.figure we can use, and fig size we can specify as, say, 14 as the width, and height as, say, 10 or something. And this is our clearer version of our chart with the legend at the top right, and you can understand how the visual is created. You can also use gender for giving color. So different color represent different gender, orange for female and blue for male. Like the way you want, you can just modify this chart. It is a very interesting chart, similar to bar, but it shows distribution in a stripped manner. So we have seen this strip plot. We have given different set of colors. Now we will talk about distribution plot. Now there is a distribution plot in Seaborn. It is used to display the distribution of the data, and it is a variation of histogram that we have seen earlier. It uses kernel smoothing to plot various values, allowing for smoother distribution of by using the smoothing out the noise. So it is similar to histogram only. It is not much, or not much of the difference is there. So if you want to create a dist plot, so distribution plot or dist plot, the kernel density estimator or KDE is used over here. So we will do what? We will use the probability distribution function. It is using the probability distribution function, that is kernel density estimator, to create this chart. Now I am calling sns.distplot. A is basically the value that is under observation, that is claim, if in case we are investigating claim. And color, we can pass any color that we want, or automatically it will detect the color as per its choice. So we will try to develop the dist plot in our data visualization. So here I am just removing everything, and instead of strip plot I will call dist plot. And in dist plot I require a value, so I will use claim out here. So claim, it is going to create a dist plot. And color, you can give any color that you want. Color is equal to, say, orange or something, so it will give orange color. If you want blue, it will give blue color. Now you can see the color gradient is also very nice compared to the color that we had in this previous. Okay, here we have an so we have a message or warning message. It says that dist plot is deprecated function and will be removed in Seaborn, the upcoming Seaborn version. So please adapt your code to either use dist plot or a figure. So we will modify the code to use dist plot. Now this is our dist plot. Instead of dist plot, we have dist plot. So they are continuing this dist plot, but yeah, for now we can use it. And color, we have specified blue. Then you can also specify KDE is equal to false. So KDE basically represents the smoothing parameter in our dist plot. So this is probability estimate value to smoothen out your existing distribution. So we can put KDE is equal to false, and the smoothing parameter is going away, and you can see a clearer histogram kind of plot. So it is nothing but our histogram only. Now we will talk about joint plot. So joint plot is used to is a bivariate plot along with distribution plot with margins. So if you want to compare two categorical values, two numerical values, that is BMI and claims, for example, so you can use the joint plot. Joint plots, it's similar to your scatter plot, giving more information about your data. So let's try to understand this joint plot and create a joint plot for our insurance data. So let's use this. I'll just copy it. What I will use is I'll do one thing. I'll use this code. Here I will call out joint plot, and x-axis I will not take. I will take age or something. So age I will take. Age is numerical figure. I will take age. Y-axis is claim, and data is equal to df, and we'll see that if it is possible to add hue also. So there is an option of hue also. So hue we will give with respect to gender. So this is our dist plot representing information. You can see this joint plot. It shows the scatter of information like this, and it shows how on y-axis value is represented here also. So it is a very advanced chart. You can see how this blue color indicates the male values, and orange color represents female value, and here also distribution of male and female claim values. This here is the distribution of male and female ages, and exactly how the scatter plot should look like is represented here. So this is our joint plot to create advanced scatter plot or advanced analysis of scatter plots. So you do not have to write much of it, you will get directly in the chart itself. Now we will talk about violin plot. So violin plot is similar to a box plot that used to represent the distribution of data. It also uses the kernel density estimator of underlying distribution of that numerical data, and it shows the distribution of quantitative data across categorical variables such that those distribution can be compared. So suppose we have a data here, we can create a violin chart. It actually looks like a violin here, and SNS.violin plot, we can use x is equal to the gender, y is equal to whatever it is, or the data we can mention, and this is how a violin plot is visible. You can use split is equal to true to divide this violin part into two halves. So that is also possible based on hue that we are going to give. So this is our current violin plot for male and female, and this is our current violin plot with respect to survival data. So let's try to create a violin plot here. We will copy the same data, and instead of this is our joint plot, I will call it out as violin, and this is our current violin plot. It doesn't look good because x is age and y is claim. So on x-axis I have to mention gender, so I am taking gender. So gender wise violin plot it is creating. This is for male, this is for female. I need to add the hue as not as gender. I want to add hue as let me take df. Let me see. I want to give the hue based on diabetic. So I will use diabetic column. So this is the color based on diabetic column. These are the two violins for male and female. Blue one basically represent yes, the person is having diabetes, and see you can clearly compare the distribution of two of it based on the hue value that you are going to give, and this is a basic violin plot. Now you can use split is equal to true to have these in a single unit. So you can put split is equal to true, and you can have both of the distribution in a single chart, where blue one represents this diabetic is yes, and orange one represents no diabetic, and both are on a single chart. You do not have to do a separate comparison. If you want separate comparison, you remove the split is equal to true, and you will see a separate comparison of this violin plot. Now we will talk about swarm plot, which is an advanced visualization. So it is the combination of strip and violin plots. So the points are adjusted in such a way that they don't overlap over each other, which gives the better representation of the data. So this is how a swarm plot basically looks like. It is a dot density like strip plot, as well as it is a combination of your violin, both of it in a single unit. So all we have to do is we have to pass like the same code. We do not have to do much of the effort, like whatever we have used in violin plot, we are using the same over here, swarm plot. And if you run it, okay, it is asking you, and we do not require the split parameter over here, and we can run it, and you can see the distribution of swarm plot. It looks like a swarm of bees, and this is how we can create. So x is gender, so gender is on x-axis, claim value is on y-axis, and data is equal to df. So it comes from the data df, and the hue or the color is given with respect to diabetic, yes or no. So you can see a mix of data, yes and no, in this, and it is also visually appealing. Like anybody who has a look at this chart can definitely like this chart. So this is also used to give you the distribution of data. We can clearly say that, yeah, below you can see the higher values. A lot of people are having the claim values between 0 to 2000, 10, 20,000. Very less people are having higher claims. So that is the distribution difference. Now we will talk about a pair plot. So pair plot is a very interesting plot, and it is used most widely. It displays the pairwise relationship between the numerical variable. So the pair plot method creates a matrix where the diagonal plots represent the univariate distribution of each variable, and the off diagonal basically represents the scatter plot of the pairs of variables. So we will use the data set, and this is the pair plot to understand the data. So what we will do is we will definitely create this pair plot considering 2 to 3 numerical columns only, because pair plot is kind of a scatter plot only. So we require numerical data for scatter plot generation. So this is our data df, and out of this df we will take only the columns which are numeric in nature. So we will take let's say day of month or age, or let me take day of month, and followed by that I will take age, then we will take BMI, then we will take blood pressure, and let me take claim as well. We'll try to create a pair plot of this. So paired, or I'll call it as numerical data, num is equal to, now this is my numerical data, only numerical columns are there, and I will create a pair plot for this numerical column. So you can see the sns.pair plot. I have to simply pass in the data. I will pass data is equal to num, and that's it. It will create a sns.seaborn pair plot. Okay, R is missing. So this is a pair plot representing these all numerical values. I'm using numerical data. So you can see that day of month with claim, how is the distribution of day of month with claim, age with claim, and likewise all other values. And you can see the distribution of claim along with claim. So if you compare the distribution of claim also, we can see a clearer distribution of this data. So if you want to compare multiple things at a single time, you can use pair plot. It can definitely help you out, at least for the numerical values. Now we will talk about count plot. Now count plot is a very interesting chart. So it is used to create a bar plot basically based on data that we are going to pass into it. So let us create a count plot with respect to data. So for that we'll do one thing. We will create count plot, and in this count plot, x-axis we will put something called as, suppose df is my data. If df is my data, we'll put something on x-axis. On x-axis I will put diabetic. On y-axis we will put something else. So diabetic is on x-axis, then I'll put gender or something, or okay, I don't want gender, I'll put data is equal to df. Okay, so this is the count of gender, male and female, with respect to it is the count of diabetic yes and no in my data. So this is the simplest version of your count plot, and it will give you the count of values. But now what if you want to add the title as well? So let us understand, if you want to put some labels on top of your count plot. So if you want to create labels, so what we have to do is we have to use plt.text. See, we are using plt.text to fix the labels over your SNS count plot or SNS chart. So it is a kind of like SNS is built on top of plt only. That is why it is very possible to create such charts. So x is equal to minus 0.1 and y is equal to 580 is something that we are specifying here, and s is equal to whatever string that we want to put, so we can put that string value. So here in our case, string value is the round figure of count plot, and we are putting the percentage symbol at the end. So let us build up this. First of all, let us calculate the percentage for male and female separately, and then we will put on top of our existing count plot. So let us create count of percentage of yes category and no category. Yes is equal to percentage of yes. So df square bracket diabetic dot value counts. Okay, it will give me all yes and no both, but I want yes only, so it is giving me yes or no both. I want only yes category, so for yes category I have to put 1. Okay, so it will give me yes category, which is 640 out of total number of values. So out of, there are df, what is the shape of df? Df dot shape and square bracket 0 is the size of data. This is 47%, and this is my label. So I will put I will multiply it with 100. So this is my label, and I will convert it yes is equal to str of yes, and plus I will add a percentage symbol. So yes is 47%. If you see, if you visualize, yes is 47%. Similarly, I will do it for no. I will put all yes and no categories in a single unit. So for no, I will put here 0. So I'll call it as no. Okay, now on top of this count plot, we have to put the label. So plt.text we are going to use. So plt.text, and I have to position this text on y-axis. If you see, on x-axis it is at this position, on y-axis I want to put it at this position. So it should be on the top of my bar chart. So manually, if you see that 620 or 630 is somewhere, it is coming around 630, above 630 it is coming around. So if you try to calculate the count of yes and no here, so we can definitely get it. So already here it is given that x is equal to minus 0.1 and y is equal to x is equal to minus 0.1 and x is equal to 0.9 for both the categories. So I will do what? I will put x is equal to minus 0.1, even we have only one category, and y is equal to, say I am giving randomly value at 640 somewhere around. So y is equal to 640 for yes category at least, and the text that I am putting is, okay, so text I am going to put, the position of the text is fixed, so string I am going to put is s is equal to yes. So this string I am fixing on top of it, so there needs to be a little bit of adjustment over the string. What is the problem? It is giving a long string, so I will do what? I will take a round figure, a round of yes, comma 2 units. So round, okay, sorry, this has to be no actually, okay, 52%, and yes, I'll take a round figure of yes, okay. So 2 units round figure we are taking, yes and no. So yes is position here. You can see approximately I have taken. If you want to get the exact value of this, so you can definitely have the count. So you can, if you run this particular value, you will get the exact count of yes and no categories. So from there you can get exact value. So it is 640, which was in which I was correct, and I will use for so here for 0. minus 0.1 we have taken, minus, now we will take 0.9 or something. Let's see where the label goes. It doesn't go well, so I will use 1 or something. See, it is positioned here. I will take plus 9 or something. Okay, so the chart is going here. I have to take 0.9 plus 0.9. So here it is getting position, but it should not be 640. It should be 695. So we will take 695. And now you can see it is positioned correctly, but here the percentage showing is not correct, so I want the no value over here. And now you can see 47% for yes and 52% for no. So that's how you can create a chart over here. Using this count plot. Now there is another plot, that is a regression plot. Regression plot is used to create a relationship between two regression relationship between two values. So we will try to, we can see the reference over here for the iris dataset, but we will use it for insurance claim dataset. So we will put on y-axis claim, on x-axis we will put BMI or something. So we'll use SNS dot regression plot. On x-axis we will put something, and y-axis we will put something, and on x-axis we want say on x-axis we will put BMI, on y-axis we will put claim, and we want data is equal to DF, and you can see the regression plot like this. Now this regression plot tells us about more information about how the relationship is there between these two columns, that is how the relationship is there between the BMI and claim. So whether it is increasing, decreasing, and in what proportion it is increasing and decreasing, we can clearly see it out here. Then we have an advanced chart which is heat map to analyze correlation analysis between two data. So heat map is used to is a two-dimensional graphical representation in a form of tabular graphical structure, representing the relationship in a form of matrix, where each matrix will have certain different color based on the amount of correlation it is showing with each other. So heat map is used for correlation analysis between variables on each axis. So if you want to analyze correlation between multiple data, you can use heat map. So here we can see the syntax of heat map. We have to simply pass in the correlation values. Annotate is equal to true, line width, line CMap is equal to blue, and whatever these all parameters are there, these are just additional parameters. So CMap is used to map the color which is blue's color. Okay, so according to blue color, light blue, dark blue, the color it will give. C bar is true is used to add the CMap color with respect to bar chart. Every bar has a color, so there is a bar we can see, color map bar we can see next to it, which is true. vmin is equal to minus vin, vmax is equal to max plus 1, which is used to specify the axis, and annotate is equal to 2 to put annotation over the data, and line width is equal to 0.5. C bar basically returns the color bar which is beside the heat map. Vmin and vmax is used to assign minimum and maximum values to anchor the color bar, so which is used to assign maximum values to get this colors. Okay, so let us create this heat map. Basically, let's understand first of all heat map, what exactly it represents. So diagonal values basically represents correlation between two similar data types. For example, sepal length with sepal length, the correlation is 1, that's why it is going to be always dark. The off diagonal entries basically represent the correlation between the pair of variables. For example, sepal width with sepal length, it is 0.11 correlation. So the color bar beside the heat map shows that dark blue color represents the positive correlation, which is plus 1, and light color or basically white color represents negative correlation. So correlation is always in positive and negative. So we'll create a correlation chart for heat map over here. So first of all, we'll use our numerical data which we have initially developed, and we'll try to find out the correlation value of it. So if you see this correlation value, so correlation value diagonally it is 1. It shows that day of month will have high correlation with day of month. If day of month is increasing, the day of month will increase. That is what the analogy is of correlation. Day of month with age, we can see a correlation of 0.00441. We will use heat map here. So SNS dot heat map, it is most oftenly used to do multidimensional analysis of data to see relationship between data, and here we have to pass in the num correlation, and when we pass simply num correlation, it is taking lighter color as dark, lighter color as high negative correlation, and darker color as high positive correlation. The positive correlation maximum is, you can see it is 0.0, and higher correlation is 0.1, we can see. So what we will do is we will try to use annotate is equal to true and little bit of modification to this chart, so it will give the correlation values as well. So which is the correlation value which is closer to 0, it is you can see it is dark color, and which is not closer to 0, it is like which will have high correlation is having +1 as the value. So we use C map is equal to, say I will take another color that is brown or something, see if it is there. No, it is not there. We'll use a red color. So red color is also not there. We will use blues only. Let's try it out. Okay, this one is also not there. Color map name blues is not there, but here we have seen color map blues. C map is equal to capital blues. Okay. So capital blue will tell you, okay, darker ones have high correlation and lighter ones have very low correlations. And vmin and vmax is used to, so vmin to specify like -1 or something, and vmax is used to specify +1 or something. So it is the correlation values that we are talking about. So lowest correlation is -1, highest correlation is +1. So lowest value I want it to be -1, highest value I want it to be +1. Okay, I want color bar here, so C bar, if you want you can put it, if you don't want you put false. Color bar will not be there in here, but ideally it should be there so that people can compare how the correlation trend values are going around. So if someone is new, he will not be able to understand what does this color talk about. Okay, and that's it in heat map and Seaborn as visualization. So Seaborn is a complemented version of data visualization library. Like not necessarily you will use it all of the time. Like you can, if you are managing all of the things on Matplotlib, it is just fine. But if you want to do advanced analytics, advanced charts, so you can definitely use Seaborn for it. So that's all in our series of Python. So thank you for watching this video, and we will see you in the next one.
Enjoyed the session? Don't forget to like, subscribe, and let us know what Python topic you'd like us to cover next.